H21 parameter of the two-port network shown in the figure. See, the equation for the calculation of H21 is equals to I2 by I1 and making V2 equals to 0. That means 10 ohms 2 I2, this is I1, this is plus V1, 20 ohms I2, we have to make output short circuited. This node I am taking as VA. So if we apply the KCL at node VA, we will get minus I1 plus VA by 10 plus 2I2 minus I2 equals to 0. VA equals to minus 20 I2. If we substitute this equation into this, we will get H21, that is I2 by I1 equals to minus 1, which is option B is correct. Find the initial value of x of s. Here we know from the initial value theorem, that is limit t tends to 0 x of t equals to limit s tends to infinite s into x of s. If we substitute this one, that is s into 2s plus 6 by s into 4s plus 2. So as s tends to infinity, the s term is going to be significant, so it is going to be 2 by 4, which is equals to 0.5. Hence option B is correct. Here the question is the Hilbert transform of x of t is. Here x of t equals to e power j 2 pi ft, which is equals to cos 2 pi ft plus j sin 2 pi ft. We know that Hilbert transform introduces minus 90 degrees phase shift in x of t, that is cos of 2 pi ft minus 90 degrees plus j sin of 2 pi ft minus 90 degrees phase shift, that is pi by 2. So if minus 90 degrees means cos waveform is going to be delayed by 90 degrees, which is equals to sin 2 pi ft, whereas sine waveform is delayed by 90 degrees means j cos 2 pi ft. If we take minus j out, here cos 2 pi ft is j sin 2 pi ft, which is equals to minus j e power minus j 2 pi ft, which is option B is correct. Here there should be a minus sign here. This should be plus. Then we will get this as a plus as well as this as a plus. So option B is correct. This Nyquist plot will give the. Here we know two relatively means in order to calculate the stability of a system from a Nyquist plot, we will take two parameters for the measurement of the stability. Those two parameters are gain margin and the phase margin. We know these two parameters are relative stability measurement parameters, because gain margin is nothing but calculated with respect to phase crossover frequency, phase margin calculated with respect to gain crossover frequency, where a gain becomes 1. Here the phase crossover frequency is the frequency where the phase becomes minus 180 degrees. Means this gives the relative stability with respect to minus 180 degrees, and phase margin will give the with respect to unit magnitude. So it gives the relative stability, which is option D is correct. Is in lead compensation, the 0 is. Here if we go for the explanation, see, if we calculate the transfer function, suppose y of s by x of s of a lead compensator, we can write it as beta ts by 1 plus alpha ts, suppose. So The angle criteria of the transfer function is equals to tan inverse of beta t omega minus tan inverse of alpha t omega. For the lead compensation, the angle must be greater than 0. Then only we can say that this is providing a lead compensation. So for that one, tan inverse of beta t omega greater than tan inverse of alpha t omega. So beta t omega greater than alpha t omega. So beta should be greater than alpha. Means we know that here the 0 is 1 by beta t, whereas pole is at 1 by alpha t. Here beta is greater than alpha, hence 0 occurs. Zero occurs near to the origin compared to the pole. Hence, option A is correct. Consider the angle modulated signal given by the equation xm of t. Calculate the value of beta. Here beta is nothing but a modulation index, which is equals to 0.4, because if we compare the standard angle modulated equation, that is AC cos omega ct plus beta sin omega mt, then we will get beta as the modulation index, which is equals to 0.4, hence option B is correct. How far does the memory of the moving average system described by the input-output relation y of n extend into the past? Suppose see y of 0 equals to 1 by 3 x of 0 plus 1 by 3 x of minus 2 plus 1 by 3 x of minus 4. Similarly, y of 4 equals to 1 by 3 x of 4 plus 1 by 3 x of 2 plus 1 by 3 x of 0. That means the output at fourth instant not only depends upon the input at that particular instant, but also it requires x of 0 sample, means 4 samples beyond that one. Hence it requires 4 times memory of the past samples. Hence option D is correct. An N-type MOSFET and NPN BJT are biased so that IC equals to ID equals to 1 milliamp, VGS equals to 1.3 volts and VBE equals to 0.7 volts. Threshold voltage for the MOSFET is 0.8 volts and the thermal voltage at the ambient temperature is given to be 25 millivolts. Find the transconductances of individual BJT and the MOSFET are. See here, we know that the transconductance of BJT completely decided by the Q point collector current, that is ICQ by Vt, which is equals to 1 milliamp divided by 25 millivolt, which is equals to 40 milliamp per volt. Similarly, the transconductance of MOSFET, that is GM, this is for MOSFET. We know GM equals to 2ID by VGS minus VT, that is 2 into 1 milliamp divided by VGS is 1.3 minus 0.8, which is 2 into 10 power minus 3 divided by 0.5, which is equals to 4 milliamp per volt. The option A is correct.